Hello and welcome to another video on IGCSE classified physics. Today we will be discussing the concept of mass and weight. Weight is an example of which quantity? Weight is an example of force, and it is measured in newtons. Weight is the pull of gravity on an object. So a pull of gravity is a force. Which is an example of a force? Of course, all of these are wrong. Weight is an example of a force, similar to what we said in the previous question. A student is weighed on laboratory scales. Which row about weight and mass is correct? The unit of weight is newtons, because weight is a force, as we just said. The unit of mass is kilograms. So the correct choice here would be choice C. In which pair are both quantities measured in newtons? In pair B, force and weight are both measured in newtons. Which statement about the mass and the weight of an object is correct? They are both affected by changes in acceleration. This is incorrect. Mass is not affected by acceleration. They are both forces. This is incorrect as well. Mass is not a force. Weight is calculated by dividing mass by acceleration. This is not correct. Weight is actually equal to the product of mass times the acceleration of free fall. So it's not a division, it's a multiplication. The correct choice is that they have different units, of course. Mass is measured in kilograms, weight is measured in newtons. So the correct choice is choice C. The diagram shows a piece of foam rubber that contains many pockets of air. Diagram 2 shows the same piece of foam rubber after it has been compressed so that its volume decreases. What happens to the mass and to the weight of the foam rubber when it is compressed? So the idea here is to understand that mass does not change when the shape of an object changes. Mass can be looked at in two ways, and this is important. So mass can be perceived in terms of the number of molecules of an object. And it can also be perceived as the ability to change or resist change in motion. So heavier bodies are harder to move. They're harder to change in a sense. If an object is at rest, it's harder to make it move if it's heavier. If an object is already moving, it's harder to make it stop if it's heavier. So mass is the ability to resist change, and it depends on the number of molecules. It does not depend on shape in any way. So therefore, there is no change in mass. What about weight? Weight is the pull of gravity on an object that has mass. So basically, it's mass times g. G depends on which planet I'm on. So if I'm on Earth, G is equal to 9.81 or approximately equal to 10. So it's a constant. So again, if the mass doesn't change, then the weight absolutely also doesn't change. So the correct choice here would be choice D. Diagram 1 shows a sealed plastic bottle containing a hollow glass sphere and a steel ball. Diagram 2 shows the same bottle after it has been shaken. Diagram 3 shows the same bottle after it has been shaken again until the broken glass is in tiny pieces. The mass of bottle 1 is M1, mass of bottle 2 is M2, and mass of bottle 3 is M3. Which statement gives the correct relation between M1, M2, and M3? Correct choice here is choice A, because we said that the shape of an object does not affect its mass. So the total mass inside diagram 1 is equal to the total mass inside diagram 2 equal to the total mass inside diagram 3. Regardless of whether it's a sphere or it has been broken to big pieces of glass or shattered into tiny pieces of glass, at the end of the day, the total mass is going to be the same. An object always has mass but does not always have weight. What must be present and acting on the mass for it to have weight? Gravitational field. Because we said that the weight is equal to the mass times the gravitational acceleration. So you need a gravitational field to get a weight. The correct choice is A. Which statement about the mass of an object is correct? It is equal to density divided by volume. This is incorrect. You'll see this in another video. The density is equal to the mass divided by the volume. So if I'm going to write mass as the subject of this equation, it is equal to the density multiplied by the volume, not divided. B says it is equal to the weight multiplied by gravitational field strength. Again, this is incorrect. W equals mg. So mass equals W over G, and it's the weight divided by the gravitational field strength. It is the effect of a gravitational field on an object. This is the weight, not the mass. So again, this is incorrect. It is the property that resists a change in velocity. This is a very important definition or conceptualization of mass. Mass is a property that resists change. Correct answer here is choice D. The mass of an object is measured on Earth. The mass is 5. The object is taken to the moon. The mass is measured on the moon. What is the mass of the object on the moon? Again, this is designed to trick you. The mass does not change from one planet to the other. The weight will change because the effect of gravity is different. But the mass has to do with the number of molecules, and this did not change when I took the object to the moon. So the correct choice here is choice C. Which statement about mass or weight is correct? Mass is a force. No. Mass is measured in newtons. Incorrect. Weight is a force. This is correct. Weight is measured in kilograms. This is incorrect. So the correct choice is C. Remember that mass is measured in newtons. Mass is measured in kilograms and weight is measured in newtons. So the units here were switched. So the correct choice here is choice C. What is the weight of an object? It's the force of gravity on the object. A is the correct choice. What name is given to the gravitational force of the Earth on an object? This is equivalent to its weight. So D is the correct choice. A student writes about mass and weight. Which statement is correct? A ship which is floating has mass but no weight. No, it has to have weight because it's on Earth. Mass is a scientific word that means the same as weight. This is incorrect, of course. Mass does not mean the same thing as weight. Mass is measured in newtons, also incorrect. The mass of an astronaut is the same on the moon as on Earth. Choice D is correct. The mass is same everywhere because it depends on the number of molecules inside the body. So the correct choice here is choice D. Which statement about mass or weight is not correct? Masses can be compared using a balance, correct? Mass is a force, incorrect. Weights can be compared using a balance, correct? Weight is a force, correct. So the choice here is choice B. Mass is a force is the incorrect statement. A spaceship approaches the Earth from deep space. Near the Earth, a force on the spaceship causes it to have weight. This causes it to change the speed and direction. Which type of force causes the spaceship's weight, and which property of the spaceship resists change? So property that resists change, we mentioned this a couple of times, is mass. So it's either A or C. And the force that causes weight is the gravitational force, not the magnetic force. Magnets are very different from the pull of gravity. So the correct choice here is choice A. An object tends to keep moving with the same speed and in the same direction due to a certain property. The object has weight due to the action of a field. What is the name of the property? What is the name of the field? So remember, tends to keep moving with the same speed is the same as resisting change. It's hard to change. So the property is obviously the mass. And the field we're looking for is the gravitational field. So the correct choice here would be choice B. An astronaut on the moon weighs less than on Earth. What is the reason for this difference, and how does his mass on the moon compare with his mass on Earth? So, of course, mass on the moon has to be same as on Earth. We know this for a fact. Why? Because the moon has a weaker gravitational field or magnetic field. Obviously, gravitational field. So the correct choice here would be choice B. A spring is stretched by hanging a piece of metal from it. Which name is given to the force that stretches the spring? The metal pulls the spring down due to the weight. So therefore, the correct choice here would be choice D. Which quantity is measured in newtons? Again, forces are measured in newtons and weight is a force. So the correct choice would be C. Which is an example of a force. We said this before. Weight is an example of a force. So D is the correct answer. A cup contains hot liquid. Some of the liquid evaporates. What happens to the mass and what happens to the weight? So some of the liquid evaporates. So the number of molecules inside the body decreased. Therefore, the mass must have decreased. And we said that W is equal to mg. The weight is equal to the mass multiplied by gravity. So if the mass decreases, then the weight must decrease because we said gravity is roughly equals to 10 or 9.81. So it's a constant. We don't really care about it here. If mass decreases, weight decreases. So the correct choice here would be choice A. A shopkeeper pours rice into a dish that hangs from a spring balance. He records the reading. Customer buys some pasta. The shopkeeper notices that the reading on the spring balance with just pasta in the dish is the same as it was with just rice in the dish. Which quantity must be the same for the rice and for the pasta? So if they have the same reading, they must have the same mass, and consequently, they must have the same weight. The satellite orbits the Earth above the atmosphere at a constant speed. The diagram shows the satellite at one point in its circular orbit, which labeled arrow shows the direction of the resultant force on the satellite at the position shown. So the reason why objects can orbit around the Earth is due to the gravitational field of the Earth, and the gravitational field of the Earth pulls objects towards it. So the force acting on the satellite has to be pointing towards the Earth, and the correct choice is choice D. A piece of steel is taken from the Earth to the Moon for an experiment. The gravitational field strength on the Moon is smaller than on the Earth. Which statement is correct? It has less mass or more mass. Of course, these are incorrect because the mass does not change from one planet to the other. It weighs less on the Moon than on Earth or more on the Moon than on Earth. Since the gravitational field on the Moon is smaller, so obviously it weighs less. So the correct choice here would be choice C. Diagram shows a beam balance. A beaker with a wire loop balances the standard masses. The beaker is then removed and hung from a spring. The spring extends by 5 as in diagram 2. The experiment is repeated with the same apparatus on the Moon where the acceleration of free fall is less than on Earth. Which statement describes what happens on the Moon? So what happens on the Moon? This is a bit tricky because you have two experiments. You have a beam balance, right? And you have a spring. So what does the beam balance compare? Compares the masses or the weights of the two objects, right? So Since on Earth they were balanced, this tells us that the mass here is equal to the mass there, right? So what do we expect to happen if we take diagram 1 and repeat the experiment on the moon? Do we expect one of them to be heavier than the other? That doesn't make any sense. So let's take an example. Let's assume that the mass here is 5 kilograms and the mass here is 5. So on Earth, the weight is roughly equal to 50, and the weight here is roughly equal to 50. This is on Earth. Excuse me. What about the moon? Well, the moon has a smaller gravitational field, so we expect the weight, for example, to be 30. But we also expect the weight to be 30 on the other side because we said that they have the same mass and they're both exposed to the same gravitational field. So even though their weights are going to decrease, they're going to decrease by the same amount. They're going to have, again, different weights from Earth, but equal weights to each other. So what do we expect to happen to the beam? We expect it to be balanced. So C and D are incorrect. What about the spring? Now, the spring extends due to the force of this guy, right? The weight of it. So if the weight decreases on the moon, then we expect the spring to extend by less than 5 centimeters. So the correct choice here would be choice B. On the moon, all objects fall with the same acceleration. Which statement explains this? So on the moon, all objects have the same weight. This is incorrect. Heavier objects are going to have higher weights. The moon has a smaller gravitational field strength than Earth. Well, this is correct, but it does not explain the fact that they all fall with the same acceleration. The weight of an object is directly proportional to its mass, or the weight of an object is inversely proportional to its mass. Of course, the weight is directly proportional to its mass. So the correct choice here is choice C. An object is suspended from a spring balance on the Earth. The same object is suspended from the same spring balance on another planet. And we can see that the reading increased. It was around 1.5, and now it's 2.5. So which statement explains the difference between the two readings? Of course, if the reading increased, and it's the same object, so it has the same mass, but the weight increases. So the mass is the same, but the weight is greater. So what do we conclude? That the gravitational field increased, that the value of G increased. So what statement explains the difference? Both the mass and weight of an object are greater on the other planet. This is incorrect. The mass is the same. The mass of the object is greater on the other planet. We don't need to continue reading. Again, this is wrong because the mass has to be the same. The spring stretches more easily when on the other planet. It has nothing to do with the planet. So this is incorrect. The weight of the object is greater on the other planet, but the mass is unchanged. This is the correct choice. Choice D is the correct choice. This concludes our video on mass and weight. I hope you found it beneficial. Thank you for listening in.